Hello, everyone, my friends, and everyone around the world. My name is Adrenaline Bazooka Prophet, and today we are going to be talking about a very interesting video in chemistry that have been a problem to a lot of students that are offering chemistry as a course or related courses. Now, and that topic is what we call, as you can see right on the board, is what we call molecular orbital and molecular orbital theory. I want to take our time to discuss it, explain it, at the same time enter what we call the molecular orbital diagram, talking about bond order and other things. So, but for today, we work on what molecular orbital. Now, the question now is, what is molecular orbital? Start from there. Simple. Molecular orbital is a mathematical what function describing the location and the wave-like behavior. Look at two things here. We said that it describes the location and the wave-like behavior of an electron in a molecule. Two things there. One, the describe the location and wave-like behavior. All these fall according to the Schrodinger equation. Now we also say that this function can be used to what now? To calculate two things now. To calculate the chemical and the physical properties, such as what now? Such as the probability of finding an electron in any specific region, and that describes what we call an orbital. And an orbital is a region or space in which there is an high probability of finding an electron. And from the molecular orbital, we move straight down to what we call the molecular orbital theory. Now, what does the theory, what is it all about? Simple. The molecular orbital theory simply states what now? Said according to this theory, all atomic orbital of the atoms participating in the molecular formation get what? They get disturbed. And if they get disturbed, how do they get disturbed first of all? When the consigned nuclei are approached nearer, meaning when the consigned nuclei of interest they get nearer or closer to each other, there is a distortion. You get me now? And we know that they all get mixed up to give rise to an equivalent number of new orbitals that belong to the molecule now. So we move ahead quickly. So we continue. Now we're talking about what we call the types of molecular orbitals. Now, and the types are basically, for what we'll be treating here, we'll make it of two types of molecular orbitals. Although there is another one which is called the non-bonding. The first one is what we call the bonding molecular orbital. Number two, the anti-bonding molecular orbital. Number three, the non-bonding molecular orbital. But remember, I have told you that they are basically, like in our work here under molecular orbitals, our diagrams will be based specifically on the bonding molecular orbital and the anti-bonding molecular orbital. Now, question: what is a bonding molecular orbital? Very simple. The opposite of what I'll be telling you now under bonding is that of the anti-bonding. Now, in the case of bonding molecular orbital, we said that it is formed by the addition of wave function. We said the addition of wave function of atomic orbitals with lower energy compared to their respective atomic orbital from which they were formed. For example, wave function is represented with this sign or with this symbol. So that the wave function of a molecular orbital under the bonding molecular orbital is equal to the wave function. If I'm working with two atoms, so it will be the wave function of the atomic orbital of A plus to that of what now? B. So this is for what now? the bonding molecular orbital. Why? It is the addition of the wave function. Just want to put that in your head. You get me? And we have established the fact that it has a lower energy compared, for example, this is R. Let me give you a sketch one. Like I'm having this is R, it will be so that if this place here is for the atomic orbital, maybe atomic orbital A, the atomic orbital of B. Now we'll be having the anti that is always higher, and the bonding which is lower. So we have established the fact that the bonding molecular orbital has a lower energy compared to the atomic orbitals that formed it. You see now? You see, it is the direct opposite of the anti-bonding. And the fact that under molecular orbital, we have established the fact that it is always stable. It is stable. That is why oftentimes we will enter the molecular orbital diagram. You will soon realize that we first feel the bonding molecular orbital before we move to the what now? To the anti-bonding. Now we run down to what we call the anti-bonding molecular orbital. We say it is formed by the subtraction of wave function of what now? Atomic orbital, and they always have higher energy, like higher energy compared to the orbital that formed them. Of course, as you can see here, it means that in the case of the anti-bonding, we'll just be having it like this. That's for. See it now. And please take note, we use the asterisk sign to signify or indicate that what we are working on is under the anti-bonding. So here becomes what now? Minus. That is how it is. Then we have said that it has that it has a net what now? That it brings about the destabilization of the bond or net disruptive effect. For example, if I'm having two molecular orbitals like of this nature, such as I'm having something which is, let's say, positive here, and here I'm also plus positive here. Now what we have, when these two combine, and look at it, in the case of bonding, it will just give us something of this nature. You get me now? But in the case of anti-bonding, there will be a repulsion. There will be a repulsion of these two, whereby one is positive, one becomes what? Negative, as in the case of what you are seeing right here. We'll move to the last one, which we call what now? The non-bonding. We said that we really talk about it here, but just that you know, for knowledge sake, that it has the same energy as their constituent atomic orbitals, and thus they have no effect on what now? On the bonding of the molecule. Now we'll talk about what we call bond order quickly. So let's quickly talk about swiftly what we call the bond order. Now there is so much specialty about the bond order. Now what is the bond order? The bond order is the 1/2 of the difference of the number of electrons in the bonding molecular orbital and the number of electrons in the anti-bonding molecular orbital. And the formula is, or mathematically, it can be written as bond order is equal to NB, which stands for the number of electrons in the bonding molecular orbital, minus the number of electrons in the anti-bonding molecular orbital over 2. Now, take note. When the number of electrons in the bonding molecular orbital is greater than the number of electrons in the anti-bonding molecular orbital, then that particular species is stable. If the reverse is the case, then it will be what now? Unstable. Now, there is so much we should know or learn about what now? About bond order. That first of all, bond order tells us swiftly. Bond order tells us the number of bonds that should exist between two atomic orbitals. For example, if I'm having between A, like A and B, and the bond order that we got from these two interactions was 1, it simply tells me that the bond between A and B is just a single bond. If it is also 2, it means that the interaction between A and B is a double bond. So if it's 3, it also tell you that it's triple bond. But again too, there is also another interesting thing about the bond order that we should come to understand. That, for example, the bond order simply tells us the stability of a particular molecule. Please take note. If a bond order gives us 0, it simply tells us that that particular molecule does not exist. Does not exist. So with the use of bond order, one should be able to know whether an element exists, or sorry, whether a molecule exists or not. You get me now? So we'll move swiftly to do a swift recap on what we talked about under molecular orbital. We described what we call a molecular orbital, and that's what we call a molecular orbital theory. And I told you that basically that molecular orbital theory was first proposed or stated by two scientists, which are called the Ohms and Mulliken, in the year 1932. And again too, that under the types of molecular orbital, that we have basically 2 types, which are 1, the bonding molecular orbital, which is BMO, and the anti-bonding. And I told you they can be obtained from the Schrodinger wave function, whereby if I'm having two molecules or 2 species with their molecular orbital of such nature, which is positive. Please take note, this is the typical diagram for it. Now, when such interaction should occur, take note, the higher one, the higher energy is the anti-bonding. And because it always gives us a disruptive effect, you have something of this nature, because it is disruptive. Which is okay. This here should be negative. But when it then gives me a bonding molecular orbital, then this is what you should have, because their missing was accurate. And on that, our next pattern is to move straight down to what we call the molecular orbital theory. Please do well to subscribe and share this video. Remember, humble self and join our lead the biological prophet. God bless you.